Hello, everyone. Good morning. So last meeting, we talked about direct proof, and now we will be talking about indirect proofs. So indirect proof is characterized by assuming that the negation of the conclusion of the argument to be proved through proof by contrapositive or proof by contradiction. So what do we mean with this? Okay, so we will be having two ways in proving our statements using indirect proof. One is proof by contrapositive, and you already have this one when you take your logic and set theory, right? So you know what's contrapositive, and you also know what's contradiction based on what you have in your number theory. So I'll not go deeper in that. I'll just focus on the manner how it will be proven using contraposition or contrapositive. So proof by contrapositive is done by assuming that the negation of the negation of Q is true, and we will show that the negation of P is also true. We will just focus on this one for today. So I'll just summarize that one. When you say proof by contrapositive, we mean to say that we will assume that the negation of Q is true, and then we will prove that negation of P is also true. Okay. So this is the thing that we will do. So we will have an example. So here an example, if 3n plus 2 is even, then n is even. So we know that if we have in the F form, this is P, and then this is the Q, right? So we need to know what's the negation of P. If you have 3n plus is even, that is 3n plus 2 is odd. So this is the negation part. And the negation of Q will be n is odd. So let's try to prove it. Okay, the first thing that we need to do is assume that the negation of Q is true. So therefore, suppose n is odd. So this is the negation. This is the negation of Q. By definition, n is equal to 2a plus 1 for some integer a. Then 3n plus 2 is then equal to 3. Our n is just equal to 2a plus 1. So we need to put here 2a plus 1 plus 2. Right? So this is the n. We substitute the n with what we had, the 2a plus 1. If we will simplify that, you will have 3 times 2a, that is 6a, plus 3 plus 2. So it will become 6a plus 5. But take note, we need to make it in a form of an odd number. So we can have this one as 6a plus 4 plus 1, right? We cut the 5. So here, if we just need to have 2, and then what's left here in this 2 is we have 3a plus 2 plus 1. And then this, we'll just let this be another number. So let C is equal to 3a plus 2. Therefore, we will have this already as 2c plus 1. Then we will have 3n plus 2 is just equal to 2c plus 1. And we know that 2c plus 1 is odd. Thus, 3n plus 2 is odd by definition. Okay, so we're done. So what we did was we assumed that the negation of Q is true, and then we need to prove that the negation of P is also true, and that's what happened. Okay. So I hope you understand it already, but if not, then let's have another example. Okay, so I'll give another example. Okay, let's try to prove this one. If x squared is even, then x is even. So we prove by contrapositive. So there, this is our P and this is our Q. So the thing that we need to do is we need to have the negation of Q, assume, and then prove that the negation of P is also true. Okay. So what we will do is that get the negation of P. That means x squared is odd. And then we also need to get the negation of Q, which is x is odd. So suppose the negation of Q is true, x is odd. By definition, x is equal to 2a plus 1 for some integer a. Then x squared is just equal to 2a plus 1 squared, because this one. What we did is we just squared the x and then squared the 2a plus 1. So here we have x squared is equal to 4a squared plus 4a plus 1. Now, we want to show that it's odd. So we need it in the form 2a plus 1. So we can have it as x squared is equal to 2, this one. So you have 2a squared plus 2a plus 1. Okay. And then we can let, can we have b is equal to 2a squared plus 2a for some integer b. So x squared now is equal to 2b plus 1. And we know that 2b plus 1 is odd. Thus, x squared is odd by definition. So we're done. Okay. Do you have some questions? Okay, so I think you already understood what is proof by contrapositive. So see you in the next meeting. Bye-bye.